Friends, welcome back to your UPSC. So today we'll start with another topic of geomorphology, that is channel morphology. But before starting, let me wish you a very happy and prosperous new year. May all your dreams come true and your hard work may take its final shape this year. And with this new enthusiasm, let's get started with our lecture today. So, channel morphology. What exactly is channel morphology? Channel morphology, it studies channel related aspects like channel pattern, channel geometry, and factors controlling these forms. Okay, so whatever are the factors, that is natural factors or man-made factors, etc., etc., whatever factors are there which control their channel pattern, channel geometry, okay, that are studied in channel morphology. Now, it includes studying of network tributary that joins the main river channel within the drainage basin. See, this is the main river and these are its tributaries. Okay, so the whole drainage system, this whole system is studied in channel morphology. Not one stream, but the whole system is studied in this. Okay, channel development is controlled by two factors. Okay, so channel morphology studies about channel development, which is basically controlled by two factors. First is water flow or water discharge. This water flow or water discharge is studied in terms of volume and velocity of the water. Okay, next is sediment movement. Sediment movement is, see, this is our river, it is flowing, it is carrying some load, suspended loads with it. So these are known as sediments. Okay, and both these factors are governed by channel slope or gradient. How? See, if the slope is steep, then the water flow will be more. Okay, and the sediment movement, because the water flow will be more, there will be more of erosion. Okay, and because of more erosion, the sediment load will increase. Okay, so channel slope and channel gradient will lead to more flow of water and more sediment movement. Now next, we have studied channel morphology. Now what exactly is channel? Channel is defined path of narrow water body. Okay, it is a defined pathway. See, the river is moving. This is a river flow. Okay, so this river has a narrow body. Okay, river is a narrow body, narrow elongated body. Okay, and it has a defined path. Okay, so this is known as a channel. Simply we can say the path of a river or stream outlined by bed, it has bed. Okay, see, if I cut this river like this, cross sectional study, this is a bed of the river and these here are the banks of the river. Okay, so the path of the river or a stream outlined by its bed and boundaries is known as channel. So channel has few characteristics. They are, first, channel is occupied by permanent, intermittent, or ep- ephemeral streams. Okay, so permanent, that is the one which flows throughout the year. Intermittent, like discontinuing, or ephemeral means the one which is which flows seasonally. Okay, so this is whole year and this is seasonal. And next is the whole size of the river channel is proportional to the valley size. Okay, so see, if the size of the valley is less, then the basin river size will also be less, including its tributaries. Okay, and if the basin is or if the valley size is more, then the river flow will be wider. Okay, so this is simple thing. Next is So channel can also be termed as strait, passage, and these terms can be used interchangeably. Okay. Now next is channel structure. Channel structure is basically this channel and its structure. It basically comprises of channel bank, channel bed, and thalweg. Thalweg is basically, this is a line which joins the deepest point. See, this is a river flowing. Okay, so the river is flowing in this pathway. So the deepest point in this river flow, like this is the bed of the river. So here, this is the deepest point. Consider this is the deepest point. So we have deepest point, like here this is the deepest point, this is the deepest point. So the line joining these is known as thalweg. Okay. Now, as we have done the channel structure, now we will look into the factors that control the channel morphology. Now, channel morphology is controlled by three basic factors. They are independent factors. Independent factors are the factors that are imposed on the watershed. These are related to the landscape aspect and control channel morphology. Okay, so these are related basically to the landscape aspects like geology, climate, and human. Okay, so geology, it consists of exogenetic and endogenetic process, both exogenetic and endogenetic process, and these are main controller of channel morphology. Next is, they determines the dependent landscape variable of the sediment supply. Okay, these three, they determine the dependent landscape variable of the sediment supply or stream discharge. Okay, now we have done geology, we have exogenetic and endogenetic, then is climate, and the last one is human. And here we can include time also as an another additional independent factor. Okay, now next is dependent factor. Dependent factor, these are those variables that respond or adjust to the independent conditions. Okay, they adjust according to independent conditions. Okay, now channel morphology is the result of combined influence of these dependent landscape variables. What are the dependent landscape variables? They are sediment supply, stream discharge, vegetations, etc. Now, how they actually are, how they actually work. So they actually adjust, they are actually the adjustment of one or more or many dependent channel variables. Okay, like either this one only can do this work or they all are included in this. Okay, so either one can work or more than one can work at a time. Now, how sediment supply work? It determines the frequency, volume, and caliber of the material delivered to the channel. Okay, so this is in sediment supply. Next is stream discharge. Stream discharge, it actually sees into frequency, magnitude, and duration of stream flow. Okay, so this studies about frequency, caliber, and volume. It studies about frequency, magnitude, and duration. Next is vegetation. Vegetation actually controls the bank erodibility. Bank erodibility and near bank hydraulic condition. Okay, so vegetation is near the banks. So if the vegetation is more, the erodibility of the bank will decrease. Okay, so this is how it controls bank erodibility as well as hydraulic condition prevailing there. And the last one is boundary related factors. Boundary related factors are channel gradient, that in it we have channel gradient that is controlled by valley slopes as the maximum possible gradient that a stream channel can have is dependent on the valley slopes. Okay, so it controls valley slope. Now next is in boundary related factors, we have bank composition and structure, which influences bank erodibility. Okay, like if the composition or bank structure is hard, then its erodibility will obviously decrease. Next is bedrock. So here we have channel gradient. Next we have bank composition. Next we have bedrock. Bedrock and another and other non-erodible materials like collo- collo- collovial, okay, collovial material, or etc., etc., or compact tills also it can include. So colluvial or and compactile like materials which are non-erodible, they may limit the lateral and vertical channel migration. Okay, and they determine the stream channel alignment. So boundary related factors include gradient, bank composition, bedrock, and last one is erodible material. Erodible material, actually they are stored in valley bottoms of the floodplains, fans and terraces. These all things we will learn in palluvial morphology. Now, these factors control channel, bank and bed as well as sediment loads, etc. So these are the factors that control channel morphology. Now we will look into channel geometry. Channel geometry is actually what happens in channel geometry is we study cross-sectional and longitudinal, sorry, we do cross-sectional and longitudinal study of channel, okay, and on the basis of its shape and size in channel geometry. So in channel geometry, before studying channel geometry, we have to understand 5 parameters, and these 5 parameters are Thalweg. Thalweg we have studied, that is the line joining the deepest point in the channel. Next is channel. Channel is, this is the origin of the stream, and this is the end of the stream. So this whole is a channel. So the connection of source with the origin is known as channel. Next is sinuosity. Sinuosity is actually, see, this is the normal path of the river which it should take, but it get deviated. So the deviation from the actual path, the ratio of deviation from the actual path is known as sinuosity of the river flow. Next is radius of curvature. Radius of curvature is deviation from the center of the region. See, if this is this is the deviation. Now we will see it must be having some center. So this is radius of curvature. Next is channel gradient. Channel gradient is slope of the river. So the slope of the river is known as channel gradient. Now these channel geometry, they actually, in it we study area of the channel. So area of the channel can be calculated by width into depth of the river. Next is wetted parameter. Wetted parameter is the area which comes under the river flow. So this is the bed of the river, these are the banks. Okay, so this is the width, and this is the depth. So parameter is simply width plus twice the depth. Okay, twice the depth plus width. Now we will simply see that velocity of the water flow is proportional to the hydraulic radius, and hydraulic radius actually is equals to cross sectional area upon wetted parameter. So cross sectional area upon wetted parameter, and this is proportional to the slope. So as the hydraulic radius increases, the velocity of the water flow will increase, as well as the slope will also be higher. Okay, but this thing is inversely proportional to the roughness. As if there is roughness in the pathway, then even if we have more slope, the velocity of water flow will be less. Okay, now we have done channel geometry. Now we will study channel fluid dynamics. Now channel fluid dynamics, it depends on basically gradient, width and confinement, roughness, discharge and sediments of the channel. Now how it is dependent on gradient? See, the slope will increase the velocity of the river flow or the channel. So simply we can see the example that in the youth stage, the river will be having higher velocity than the one in the mature or old phase. Okay. Next is width and confinement. So width and confinement also are directly related to the speed, as the more the width, the lesser the speed. Because what will happen is, see, if we have less width, then the water or the ratio of water that is touching the edges of this bed or the wetted area of this river will be less. Okay, but if the width is more, then what will happen is the friction, the water will touch this area more, and as it will touch the bed of this channel, there will be more friction, and because of more friction, the speed will automatically be slowed down. Next is roughness. Roughness is also like inversely proportional to the speed. Next is discharge. Discharge is actually calculated as width of the channel into depth multiplied by velocity of water. So it is a product of width, depth and velocity of water. So it is directly proportional to velocity. The more the discharge, the more will be the velocity. Next is sediments. So sediment can be uh, categorized or classified into three types. So the first one is suspension. Suspension. Next is solution, and the other one is bedrock, bed load. So see, solution is the one that totally mixes in the like NaCl or MgCl. So the salts, they basically mix in the water, so they will not hinder the flow. Next is suspension. Suspension is the particle that flows with the river or with the stream. Okay, so they are basically the one which forms alluvial soil and all. Next is bad load. Bad load is it is hard pebbles, big pebbles, and boulders, etc. They are very heavy to carry, and they are first they are cut it down, but later they are placed and they are not taken away furthermore. Now, on this basis of channel fluid dynamics, or with the influence of channel fluid dynamics, basically channels are formed in two ways. First is uniform or non-uniform channel. So uniform channel are the one which have straight path. Um, so they have straight path and their velocity is uniform. Or we have non-uniform channel which have curved path or tilted path. Next is steady and non-steady channel. Steady is related with time, as with the time they remain the same. Okay, so they do not change, and unsteady one are the one which changes with respect to time. So this was the channel fluid dynamics. Now we will study channel bed topography. Now, channel bed topography occurs when a river has sediment, and the sediments also should be more rough and porous. Now, on the basis of this, we have basically two types of channel bed topography. First is riffles, and second one is pools. Riffles occur in shallow water with porous sediments, okay, and they are formed over a crossover between two meanders. So these are two meanders. When they cross over, this area will form riffles. And second one is pools. Pools actually occur in deeper water with finer sediments. So these have more porous sediments than these one. So they have finer sediments and calm water, and they are formed at the outer edges. These are outer edges. These are erosional edges actually. So they are the site of active erosion. So here we can find pools. Now we will study hydraulic geometry. Hydraulic geometry is governed by the flow or discharge of water. Now we have calculated that how can discharge be calculated. We have learned this formula. Now let's revise. That is width into depth into velocity of the water. Okay. So hydraulic geometry can be calculated in two ways. First is at the site hydraulic geometry, and second is downstream hydraulic geometry. Here, the flow of water over a period of time at a certain location is calculated at a site hydraulic geometry, and another one that is downstream, we will calculate the special spatial variation or changes in the pattern of landscape pattern. Okay. Now we have completed hydraulic geometry. The last topic is channel types. So channel type can be basically channels can be classified on three types on the basis of three things. First is on the basis of gradient, second is on the basis of pattern, and third is on the basis of constituent material. Okay. So on the basis of gradient, we have two types. First is low gradient, the channels on the in low gradient, and next is channels in the high gradient. So channel in low gradient, we will see straight channel. Okay. Then we have meandering channel. Meandering channel is like this. Okay. So when the river comes in its mature and old stage, we will find the one in low gradients. Okay. So meandering river or meandering channel. Next is braided channel. Braided channel is actually when we have this river and the sediment loads are deposited in between, which will form island group type things. So these are known as braided channel. And next is entomosing. Entomosings are permanent multi-channels. See, like this is braided one. Here what will happen is in entomosing, this river will flow, it will divide into two, then it will again come together, they will divide again. So this is permanent multi-channeling of the channel. And next is wandering river. Wandering river is basically a structure between straight channel and meandering channel. So meander is this type of path and straight is this type of path, then wandering one will be this type of path. Okay. Next is high gradient channels. So high gradient channels are one which are in youth stage. Okay. So first we will have when the gradient is 1 or 2%, then we will have riffles or pools formation. Next is rapids. Rapids are small waterfall types of thing. They are like steps, and here the water flows. So rapids when there is 5% of gradient. Next we have step pools. Step pools are also like this. They have 20% of gradient. And lastly, when we have more than 20% gradient, we have cascades and waterfalls. Next is pattern based. So this is basically based on how the river flows. So on the basis of river flow, we have straight river channel. So straight river channel is like having a straight path. Next is sinus. Sinus river channel is deviation from its original path. Okay, so this is little bit curved. Next is meandering river. Then we have braided river channel. Okay. Now last categorization of channel is on the basis of constituent material. So on the basis of constituent material, we have basically bedrock channel and alluvial rock channel. So alluvial rock channel is the one in which when river cuts the river transported rock debris or alluvium, these are referred to as alluvial channel. So river is flowing and it cuts down the debris and all that, so and they are transported with it, so this is known as alluvial channel. Next is bad rock channel. Bad rock channel is the one in which the river bed having cover of rock rather than sedimentary cover. Okay, so instead of sedimentary cover which gets eroded very fast, it it will have rock cover. Okay, uh, which will make it difficult to get eroded. Okay, so in this one we have bed bedrock. Okay, and when the river will flow, it will flow through non-erodible materials such as bedrock, porous colluvium, or non-erodible glacial deposits, and their boundary conditions tend to dominate the channel morphology. So when they will not change, okay, they will not change because they are having hard rock structure. So because of which they will tend to dominate the channel morphology, and they are insensitive to any sort of disturbances, including upstream disturbances also. So this was according to constituent material. This was bedrock channel and alluvial rock channel. So now with this we have completed the channel types or classification of channels. So these were of basically of three types, and we have completed them. And with this we have completed our channel morphology. So that was all for today, guys. I hope you enjoyed today's lecture. So let's meet in our next class. Till then, take care. Have a nice day.